In this episode, you will learn about the application of embedded machine learning in industrial IoT. We discuss the benefits of machine learning at the edge of IIoT network, current applications of embedded machine learning in industrial systems, factors to consider when choosing an embedded processor for machine learning, and the Edge Impulse development platform. My guest on this episode is Zin Kyaw. Zin is a senior user success engineer at Edge Impulse, where he works with the Edge Impulse developer community and partners to deploy successful embedded machine learning applications at the edge. He has previously worked as a senior IoT systems architect at Crocker Technology. He was the founder of Connected Widgets, and he's also worked as senior applications engineer for companies like Cypress Semiconductor and Texas Instruments. Zin holds a degree in electrical engineering from the University of Southern California. Quick thank you to our sponsors. This episode is made possible by HiveMQ, the providers of an enterprise-grade MQTT broker, and Opto22, manufacturers of reliable industrial controllers for automation and IIoT applications. Welcome to the 4th Generation podcast here on Industry40.tv, which is a series of weekly interviews designed to help you learn IIoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the videos. If you find this conversation useful, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Mandi Teresa. Now, here's my interview with Zin. Okay, Zin, thank you so much for joining us, and I would like to welcome you to the 4th Generation podcast.
Yeah, thanks, Kudzai. Thanks for having me here.
Okay, so today I really want to talk to you about embedded machine learning for IIoT. Now, to start off this session, we all know of the many benefits of machine learning, but yet when it comes to industrial equipment, the uptake has been relatively slow. What do you see as being the biggest challenges to the integration of machine learning in industrial equipment?
Yeah, I think, from my perspective, there are, maybe it's not so much challenges per se, but, I think when we think of embedded machine learning, it's still a relatively new field, in terms of like today's technology landscape. Most of the machine learning has been done, primarily been cloud driven, all of the algorithm development, all the applications that are running with regards to machine learning. These have mainly been executed in a cloud server-based environment. But now we're kind of at this intersection between embedded devices and machine learning, where a lot of people are starting to realize that, hey, we can actually utilize the power of these processors on the edge and start using them to advantage, instead of just treating them as, I would call it like dumb devices. Like when we think of like sensor devices, most of the sensors that are out there don't do a lot of compute on the device. They just read the sensors and then relay that information to a server somewhere. It can be in a cloud framework or some private cloud or something like that, right? And all of the number crunching and processing analytics gets done in the cloud. And so I think we're at the stage right now where folks in the industry are starting to see more value in putting more intelligence back at the edge and discovering how to do that efficiently and also manage that efficiently too, because, we also come from this sort of IoT background, right? And the last 10 years have been pretty much about IoT device management. And when you look at deploying machine learning on embedded devices, that then does become another part of device management in a sense. And so I think the industry is learning how to fuse those two together and make them essentially as one deployment, right? Because in the end, you're going to have to manage these devices somehow. So device management is still going to be there, all of the IoT stuff that we've learned over the last 10 years. But then now we're adding a new wrinkle, a new piece of the puzzle, which is let's put embedded machine learning on these devices to put the intelligence back at the edge. And so So I don't see it more so much as challenges as more just like a natural evolution of this, industrial IoT space is like, okay, here we have another tool in our tool belt that we can put to use, to help realize the applications and make them more efficient. Rather than just blindly sending every single piece of data to the cloud, you're only going to make that cloud infrastructure bigger and bigger and bigger as you
Yeah.
scale the number of devices. That's, I've seen that through my own experience, working with, different cold chain management applications. When you're talking about millions of sensors, tens of millions of sensors, that is a big scale. And, to support that kind of data and storage of that data, that requires a lot of cloud infrastructure, when we think of the ultimate scaling factor. And so I think, and also management of that data, being able to provide enough systems on the backend side to be able to crunch through that data in an efficient manner, becomes important. And so I think, not so much challenges, but you're going to see an opportunity to optimize the systems that we're creating also on the backend side. If we are able to transmit less data, but also transmit more meaningful data, then our algorithms on the backend side can also become more efficient, and the systems required to support those algorithms can be more efficient as well. And so it's really a nice marriage, I think, of these two worlds where you have the cloud environment, you have the embedded devices, and there are a lot of synergies there when you try to apply machine learning on the edge.
Oh, okay. Do they always work in hand, the edge-based machine learning and the cloud-based, or is there a situation whereby you'd want to have entirely the machine learning running on the edge? What are the benefits of having run entirely at the edge of the network?
Yeah. So, I tend to think of these problem domains very holistically, like from a high level system perspective. And so if, you have this sort of traditional approach of doing everything in the cloud. And then now I think folks are starting to realize that, hey, like there's a lot of stuff we can do on the edge. And for me, a lot of it is improving system latency. Like that has been a big thing, I think, when we look at only cloud-based systems, is the round trip time. And this is where I talk about the scaling factor. If you're looking at like just 100 nodes, probably you're not going to see the impact of that. But when you scale to like a million, 10 million, 100 million nodes, to be able to process that amount of data and have a fast enough response time where you can take action, right, is something I believe quite challenging for people to implement on a large scale. And this is where embedded machine learning at the edge can really shine, because if you put the decision making um, piece of the puzzle at the edge, you're going to be able to get a faster response time at the edge. For example, I use the example of a common case where, let's say in a grocery retail store, one of the typical cold chain management applications is to identify if a walk-in cooler, full of produce and everything, has been open or closed. Because the longer that it's been open, the more chance that the product inside is going to deteriorate. Now, you want that notification to the store manager to be almost instantaneous. You don't want to have to wait minutes for somebody to take action, because by that time the product could be, quite compromised. And so those are the kind of advantages that I see clearly for deploying embedded machine learning at the edge. Is, let's put more intelligence back at the edge where we can have a faster response time and have a quick action. And that's where you're going to see the real value, right? Instead of, it really defeats the purpose if somebody's opened the door for 5 minutes, but then you only get the notification 15 minutes later because it's taken that long to crunch all the numbers from all the sensors. And then, oh, it's like this store had a problem with the walk-in cooler. So there's that inherent overall system latency if you're putting all your eggs in one basket, with back-end processing only. And so this is where the combination makes a lot of sense. Like, let's put intelligence that matters on the edge where it makes sense. And then, of course, that is always going to be complemented by all of that infrastructure we already have on the back end.
Oh, okay.
And so I never see these problem domains as a binary thing, one or zero. It's always going to be some complementary way of working together that's going to be probably the best, going to give the best solution.
Okay, awesome. So you have already given us a very good example there. Maybe for the benefit of the audience who are more familiar with the industrial kind of factory floor setting, do you have some examples that you could share with us of the current applications of embedded machine learning in a factory floor setting?
Yeah, so we recently did a proof of concept actually with regards to wheel lug nut detection. So this applies directly to the transportation industry. So one of the things that we found out is that these wheel lug nuts, they're very small, but they're extremely important for the safe operation of an automobile. Because even if one of those lug nuts are missing, let's say it could be a brand new car that comes off the factory floor, that could be a safety issue. And there's been well documented safety issues in the past where automobile manufacturers have had to recall cars because there hasn't been enough done there in terms of quality control. So we used our object detection pipeline that we built into Edge Impulse, and was able to create this kind of proof of concept that shows how we can detect these wheel lug nuts, and identify whether all of them are in place, and then if so, provide the necessary outcome to the user that says, okay, like kind of QC passed. So that's kind of the idea, is that we can envision these kind of systems being more commonplace in the manufacturing plants and things like that, where we use computer vision to help us determine, get us to a next level of quality control. And this is where I think we see a lot of applications is using computer vision for this to automate those processes versus anything that requires manual inspection. I think there's a big opportunity to automate that with computer vision and streamline all of these processes. And that's a perfect example of the marriage of embedded machine learning as well as backend infrastructure as well, because we plan on leveraging services like Azure IoT to be able to send those outcomes to the Azure IoT based services. And then you could have some application running in Azure, for example, that would understand, for example, how much what kind of quality control we have for different manufacturing plants, right? And so there's really no use in just sending the raw data to the cloud. Like we can already do that on the device itself. So if there happens to be a situation where there is some, like a car on the manufacturing line that does not already have all of the lug nuts in place, you can identify it right there and then and fix the problem at the manufacturing line. You don't need to wait until the car is already off the line, and then by that time it's a costly operation to bring it back on. You know what I mean?
Yeah.
So so that's going back to my example before, like system responsiveness is king. Like I feel like being able to have do it in a matter of seconds to 100 milliseconds is like very critical for capturing the problem as it happens and not minutes later when it's too late, just due to the round trip time of processing all that data in the cloud. So that's a great example. We showed how we can combine machine learning algorithms from Edge Impulse and Azure IoT to be able to create this fused solution where we could see that in place down the road.
Oh yeah, absolutely. Okay, so for equipment manufacturers or or developers that may be looking at integrating machine learning into their products, what would you say are the factors to consider when selecting an embedded processor for machine learning?
Yeah, that's a really great question, and I think probably very a wide spectrum of answers there as well. But I'll try to give some context on that. So I think at the end of the day, it comes down to the three P. I call it the three Ps, which is power, price, and performance. So it really at the end of the day depends on the application and how much you're willing to put forth in terms of resources. But so I'll give you one example. Like in the case of this wheel lug nut detection example, you probably have more of an emphasis on performance. Like this thing needs to be fast, this thing needs to be accurate. So you generally probably will lean more towards a faster processor. Maybe it's something that can run embedded Linux. Maybe it's an x86 type single board computer type thing. With more sophistication around computer vision. I think when you start looking at more sophisticated applications that involve object detection and things like that, you probably will find beefier processors that's required to run those algorithms. Now, that's today's landscape, but who knows in the future? Because one of the things that at Edge Impulse we work with is a wide variety of ecosystem players, including silicon manufacturers. And so, we work with a lot of the silicon players, and they're always innovating in terms of the chipsets. Like, today, I don't know if you remember, but like, 5 years ago, 256K flash was like this, like a lot of space for like a microcontroller, like, but now the normal is like 1 megabyte, of flash and 256K of RAM. So it's like every 5 years, we're seeing this quantum leap in terms of evolution of the processors that are out there. And so, perhaps 5 years from now, we could do all of this sophisticated object detection stuff with an MCU, right? And that will become the mainstream. So we can kind of see this this evolutionary path. And I think machine learning will help. Embedded machine learning will definitely help drive the evolution of the silicon landscape as well. But of course, power consumption is also very important. So like one of the areas that we look at too is measurement and sensing. So the cold chain scenario that I described, these are battery powered sensors which need to last for 10 years, on a single cell. And so when you get to that kind of constrained device, you need to be as power efficient as possible. And also with transmitting the information to the cloud. So the communication medium needs to be efficient as well. So the radio that's on these MCUs, they need to be managed efficiently. And then a lot of people want to do this for cheap too. Like, the BOM, if you look at the BOM cost of these sensors, they're usually, $10 or lower. And so, generally you have these sort of different classes of processors and technology that, it depends on a lot of, again, this three Ps of price, power, and performance. Like, how do you calibrate those three pillars to meet your application requirements? And generally you're going to be, somewhere along the spectrum. And so, that's kind of would be my advice to folks that are looking at the processor selection is, if you want to have low power, low cost, you're probably going to be, at least today, still in the MCU domain, like your Nordics, your Scilabs, what have you, your TIs, right? That have a single SoC microcontroller. But if you're doing more sophisticated applications like object detection, that's probably going to put you in a higher bracket of like more of a single board computer type thing, at least today.
Oh, yeah. Sure, yeah, that makes a lot of sense actually. So, like, can you take us through a typical workflow for developing and deploying machine learning models on an embedded processor?
Yeah. Yeah. So, at Edge Impulse, we provide a complete one-stop shop embedded ML platform that basically walks you through the entire process from soup to nuts. So from data acquisition directly from the device to, we call it data wrangling, which is, formatting that raw data into um, a form that can be then fed into a machine learning algorithm. And so we have a number of DSP blocks that are part of our platform that allow you to extract, we call it like features from the raw data. And this feeds in directly into our neural network pipeline, which allows you to train different kinds of models from measurement and sensing to audio to computer vision. And so, that's kind of the overall process, in terms of uh, getting a machine learning model deployed is, data acquisition, DSP, and then training that model. And then finally, of course, you want to be able to deploy that efficiently. So we provide the ability to deploy these models in various ways, but one of the most popular ways is as an embedded C++ library. So you can actually literally export the model and all of our SDK to a C++ library that can be linked into any kind of embedded tool chain. So that's really versatile because that gives you the capability of deploying your model on literally any device that's out there. Even we call it brownfield devices. So even devices that are deployed in the field or use existing MCU architectures could be utilized for that. Doesn't necessarily need to be a brand new device, which is something that is seems to be resonating with a lot of folks now because of all this like silicon shortage stuff,
Yeah.
in the industry. Like, so folks that are building new devices, well, they can't get the silicon that's required for building those devices, in a short amount of time. And so I think a lot of folks are looking at how can we essentially upgrade our existing devices to have more intelligence. And so, this flow that I just mentioned would be very applicable to that as well. Um,
Oh, okay.
so, yeah, I mean, our machine learning pipeline is quite broad. There are some folks out there that only focus on one or the other pillars, but we provide support for computer vision, audio, as well as measurement and sensing. So this this has really been delighting folks that are creating all kinds of different applications.
Oh, okay. So do you have like do you have like an integration mechanism with some other standalone software frameworks, like maybe your TensorFlow, or is there even a need to actually integrate with other software frameworks?
Yeah, we've chosen basically TensorFlow, Keras as our underlying framework for the machine learning piece, and also provided additional optimization beyond that. So we have something called an Eon compiler, which essentially takes the TensorFlow Lite output and um, essentially compiles that directly to a C++ library. So it gets rid of the interpreter overhead that's required for TensorFlow Lite, and this allows us to really reduce the amount of ROM and RAM that's flash and RAM that's required, because as you know, like for MCUs, every byte is critical. Like people
Yeah.
are trying to figure out how to save RAM. RAM mostly is the big premium, getting everything to fit. These days, as I said, it's not so much of an issue because folks are coming out with like 256K of RAM and stuff like that. But when you get to cost optimization, this is where you start seeing a little bit less RAM these days. In the future, maybe that won't be such an issue, but you know, um, that's our focus though, is providing the most optimized embedded model that can run on these MCUs, right? We're really
Yeah.
pushing the efficiency knob. And so our Eon compiler really helps out with that, saving 25 to 50% on RAM is a big deal.
Oh, yeah, absolutely. Okay, so now we know that with machine learning, you need data, for you to build models. So, do you feel like there's enough industrial data available to build effective machine learning solutions? And if not,
Yeah.
how would organizations approach that problem?
Yeah, that's a great question, actually, and we see that all the time with our own customers and whatnot, and our developers. Is as you alluded to, everything starts with the data, right? I mean, that's the whole
Yeah.
point of machine learning. Is if you don't have the data, then well, that you're not going to do much. Yeah, I think this is also a growing field. There are, I think, a lot of open data sets that are out there that can be utilized. For example, we've done some studies on mode occurrent signature analysis, and try to leverage some data sets that are out there, to help create some frameworks around that. Um, and there's a lot of data, other data out there too, like temperature, humidity, things that lend itself well to cold chain management, and also like smart agricultural applications. There are people that have collected a lot of data out there already, because all of this data has already been sent to the cloud somewhere.
Yeah.
If we think of industrial IoT, that data exists. Now, can we get access to that data somehow? I think we can, because these are also the same people that have been implementing this from a device management perspective. And so I think that data does exist generally in the industry today. And now, the concept now is to take a second look on that data, and then create a model that can run on the edge device based on that. Um, you know, so that's so in one sense, there might be some cases where specific data doesn't exist, but that's also where we're helping people collect that data easily and securely. And so data collection is still a fundamental exercise of algorithm development for machine learning, even if it's on the embedded device. And we're providing tools to be helpful with that, and make that an easier process. And so so I think the industry has a pretty good start overall, but
Okay.
every application is unique. So I think at the end of the day, it does come down to analyzing each specific use case, for a specific given client, right?
Yeah.
They have their own problem that they're trying to solve, and if data uh, data doesn't already exist, then it should be easy to acquire that data in the field, and that's what we're striving for.
Oh, okay. All right. So now, when it comes to deep learning in particular, where do you see it being applied the most in industrial control applications?
Yeah, I mean, we're seeing a lot of different areas, as I mentioned, in manufacturing settings, you know, um, predictive maintenance settings, for example, folks that are looking at HVAC equipment and trying to understand whether they can get a head start in terms of early failure warning. That's an area that comes up a lot in predictive maintenance, is um, understanding the patterns towards a failure mode, and alert the system owner if the equipment is headed towards that. Any sort of situation where you're dealing with cooling, big fans are involved, right? So that's one of the things we get to, as folks that are interested in understanding when a specific cooling unit might be heading towards failure. And then also in areas of like smart agriculture as well, where you have a lot of different sensors, like in terms of temperature, humidity, lux. These
Yeah.
these tend to be the sort of three main metrics that um, folks measure when it comes to uh, sort of produce yield. And so being able to um, create some algorithms based on those metrics, helps like farmers, for example, get more produce out of their farms, and things like that. So there's a very wide, I would say, a spectrum of areas where this embedded machine learning can be applied. We're seeing, there's not really just one area that folks are concentrating on. It's basically, I think folks are looking at it as um, an additional tool that can help them actually really solve these problems that they're facing, and versus the traditional methods of just uh, sending all of their data to the cloud and doing the analytics there.
Yeah.
But now we can actually put that intelligence back, towards the edge, where, again, as I mentioned, getting a faster system response is key to that.
Oh, okay. Yeah, awesome. Now you've already mentioned that it's hard to tell what the state of the embedded processor market will be like say in 5 years or so. But could you give us a glimpse of what you see as the future of embedded machine learning in industrial assets?
Yeah, exactly. As I touched upon a bit earlier, I think we're going to see sort of this, if we look at the MCU as one side of the spectrum, and then you have the single board computers as the other side, right? You're going to see those universes converge more and more, where there's going to be this really gray line in terms of what is a single board computer going to look like in the next 5 years, right? I think we may all be surprised as to what that is.
Yeah.
I think one of the things we're starting to see trending up is the addition of more neural network accelerators in MCU devices. And that is probably going to open a lot of different doors for where we can go next, because I think traditionally that has been the sort of area where you could see more improvement, because to process these algorithms, you need to have processing power. If you can offload that from the CPU to a more dedicated processing unit, which is basically where a lot of these manufacturers are going, is then going to be very interesting, because all of a sudden you can start getting much better performance on the MCUs in terms of processing these ML algorithms, and also do it for a fraction of the power. And so I think you're going to see this convergence happening, and it'll probably happen within the next 5 years, I would imagine, because if you think back to like the original iPhone, I mean, it was like what 2000, what was that, like 2007 or something, like yeah, right. I mean, and then so literally just over 10 years, I mean, like you probably wouldn't recognize the original iPhone from what we have today. So I could imagine the same thing happening for the MCU industry as people put more and more into it. And I think you'll see this convergence, and a single board, the definition of a single board computer changing.
Oh yeah, absolutely. Okay, now your company Edge Impulse, you've built quite a remarkable tool set for embedded machine learning development. Could you give us an overview of the Edge Impulse ecosystem?
Yeah, absolutely. Yeah, I mean, as I mentioned earlier, we work with, basically all the top silicon manufacturers, and we've been working with them since day one to build up an ecosystem that's rich in terms of silicon partners, first and foremost, because it really all starts there. And then we've also been working hard on nurturing a developer community. I think it's, close to, getting to over 20,000 developers today that are active in the community. And we're aiming to get to 30K by the end of the year. And so really a great marriage of folks that are interested in developing real applications with embedded machine learning, powered by a variety of silicon manufacturers that we've partnered with. And really this provides the genesis for then reaching out to folks that are actually deploying real applications out there in the field. And this spans across, thousands of enterprises worldwide. that are looking to realize embedded machine learning applications. So, it's really sort of this three-prong approach, I think, where uh, you have the silicon development community, you have the developer community, and then you have the enterprises that are looking to deploy these out there for industrial applications. So, and this whole ecosystem works very synergistically, as you can imagine, because at the end of the day, it's really all about deploying these devices at the edge, and um, you know um, everybody gets to participate, essentially, all
Yeah.
up and down the software and hardware food chain. And so I think one of the things that we've been really successful is galvanizing that entire community, together, to help reach some new heights, in terms of what we can do with MCUs, pushing the envelope in terms of
Yeah.
power consumption, how much can actually fit on the device. And, we'll continue to innovate there in terms of what we can do with these devices. So we're really pleased where we are right now. And, we'll, work hard in terms of continuing to grow that ecosystem, and, continuing to sign up new silicon partners as well. Uh, we just recently announced, a partnership with TI not too long ago, and we'll continue to add more partners as we go along. But I think it's really exciting because you're going to start seeing these new kinds of devices that I had mentioned earlier, with
Yeah.
like actual accelerators on the MCUs, that will push the boundaries of what we can do. And the ecosystem that we've built gets to, you know, see the fruit of that labor and benefit from that too. So it's sort of this, yeah, I guess that's why we call it an ecosystem,
Yeah.
because
Yeah.
everyone benefits from forward progress. So we're
Absolutely.
really happy about
Absolutely.
that.
Absolutely. Okay, now lastly, well, this channel is really for developers and engineers. So I'm sure some of them, they might be interested in knowing precisely what platforms could they go to, to participate, to be part of this developer network. Do you have like some GitHub or platforms, or
Oh yeah.
any site that you could send developers to?
Oh yeah. I mean, we have a wealth of resources on our main site. So the best place to start is probably our documentation site, which is really rich in resources. So that's
Okay.
docs.edgeimpulse.com.
Okay.
And there you will see basically this giant list of silicon vendors that we already support today. All of them have some kind of development platform that they provide, and we've provided software support for that. All of that code is available in GitHub, so we have the links right there. People can go look at that code and run it themselves. The C++ library that we use to export after the model development that comes out of Edge Impulse, that is also basically full source code under an Apache 2.0 license. So, very permissible license that allows developers to actually go and deploy devices out there for the applications. You know, instead of being held back by some arcane license agreement or royalties or something like that. We're our business model is not royalty based. It's project based for our enterprise customers. So for developers, they are able to just go ahead and run their apps, without this sort of concern of, oh, like what's behind the license agreement,
Yeah. Yeah.
this kind of thing. So the concept of our whole platform is, we want to make it as open as possible for developers, and they can definitely see that through our documentation website. Like a lot of the resources that we have available are all open to them. So this makes it easy for them to get started, all the way from conception, proof of concept to production. That is our goal, is to help developers do that.
Oh, okay. Awesome. All right. So
Yeah.
that brings us to the end of our session here. Thank you so much for taking the time out to come and join us here on the Fourth Generation podcast. I will link the website in the description for those who are interested in going to check out the code and start playing around with the solutions.
Awesome. Thank you,
Okay, so
Kasai. Thanks for
thank you
having
so
me.
much.